Okay, this is a test 2 review. Throughout this video, I'll show examples, and then I'll put an example up for the student to work themselves. And where it says pause the video to give students time to fill out this circle, well, whenever you see the red, that means pause the YouTube video, and then work the given problem, and then continue on. So at this time, go ahead and pause this video and let the students fill out the unit circle. Okay, now let's take a look at the unit circle. I'm going to fill this out, and get my pen to work here. There it goes. Well, we'll look at the degrees first. This is 0. Now, as we go around, we'll keep adding. Well, first, let me fill out the 45 degree. This is 45 degrees. So we got 0, 45, and then 90. And we're going to keep adding 45. So 90 plus 45 is 135. Hopefully my eyes don't get off here and I put it in the wrong place. Plus another 45 gives us 180. Okay, plus another 45 gives us 25. Plus another 45 gives us 270. Plus another 45 gives us 315. And then plus another 45 brings us back to 0, so this is 360 degrees. Okay. Now, excluding the quarter marks, which and of course the axis, the x-axis and the y-axis, if we look at the rest of them, we just keep adding 30 over and over. So start with 0 degrees, plus 30 is 30 degrees, plus another 30 is 60, plus another 30 is 90, plus another 30 is 120, plus another 30 is 150, plus another 30 is 180, plus another 30 is 210, plus another 30 is 240, plus another 30 is 270, plus another 30 is 300, plus another 30 is 330, then of course another 30 is 360. Let's take a look at the radians. Start with 0 here. Let's look at our quarter marks first. This would be pi over 4. We keep adding pi over 4 over and over. So 0 plus pi over 4 plus another pi over 4. So we got 0, pi over 4, 2 pi over 4. But 2 pi over 4 simplifies to pi over 2. It's pretty small. Okay, so pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4, which is the same as pi. And then down to here, this will be 5 pi over 4. This will be 6 pi over 4, which reduces to 3 pi over 2. And then this will be 7 pi over 4. And this will be 8 pi over 4, which is the same as 2 pi. Okay, now back to the excluding the quarter marks. We're going to keep adding pi over 6 over and over. So 0 plus pi over 6 is pi over 6. So 0, pi over 6, 2 pi over 6, which is the same as pi over 3. So pi over 6, 2 pi over 6, 3 pi over 6, which is the same as pi over 2. 4 pi over 6, which is 2 pi over 3. 5 pi over 6. 6 pi over 6, which is the same as pi. 7 pi over 6. 8 pi over 6, which is, what is that, 4 pi over 3? 9 pi over 6, which is the same as 3 pi over 2. Let's see, 10 pi over 6, which is 5 pi over 3. 11 pi over 6. And then 12 pi over 6, which is the same as 2 pi. So that's how you can easily build your degrees and radians. Okay, now let's do our points that fall on the x and y axis. Those are the easy ones. This point over here, as I said, they're easy. Watch me mess it up. That's 1, 0. This will be 0, 1. This over here will be negative 1, 0. And this one down here will be 0, negative 1. We should know those from pre-algebra. Now the quarter marks. Pi over 4. This will be square root of 2 over 2, square root of 2 over 2. This one will be square root of 2 over 2, square root of 2 over 2. By symmetry. Then this one down here will be square root of 2 over 2 and square root of 2 over 2. And then this one will be square root of 2 over 2 and square root of 2 over 2. Notice how they're all square root of 2 over 2. So this is symmetry. If I went straight over here, then, you know, if I were to flip that point over, it would land exactly on this. And if I go straight down to here, same thing, straight over to here, so forth. Okay, now in this this quadrant here, our x's are negative. So that'll be a negative square root of 2 over 2 there. And the third quadrant down here, both x and y are negative, so this will be negative, and this will be negative. And over in our fourth quadrant, the y is negative, so I'll put a negative there. Okay. Now these other ones. One of these will be, and I'm looking at the x part first. One of these will be square root of 3 over 2, and the other one will be 1/2. And you can sit there and derive that if you don't remember it, but that's probably the one thing. I mean, you have to memorize some of this, but if you just remember square root of 3 over 2 and 1/2, then you pretty well have it. If I look at this point, and I look at this point, if I come straight down to the x-axis, here and here, this point is further out in terms of my x values, which means this will be square root of 3 over 2 and 1/2. And here, this will be 1/2 and square root of 3 over 2. Try to write that a little bit cleaner. Should have had this bigger, I guess. Okay. Again, this one's further out to the right in terms of my x values, so it should have the larger number on top, the square root of 3. This one's closer in, should have the smaller number, which is 1. And then these are just, if this is square root of 3 over 2, this is 1/2. Okay. Now if I come straight over from this point over to here, this is also going to be 1/2 and square root of 3 over 2. On this one, if I come straight over, this one will also be square root of 3 over 2 and 1/2. But remember our signs. Let me go ahead and put the signs in, then I'll fill in these last two. Over here, we said our x is negative, so that's negative, and this is negative, and our y is positive. Okay, down to here. Hopefully I can show this. If I were to come straight down from this point, down to here, then this one will also be square root of 3 over 2 and 1/2. And this one, if I were to come straight down from here, this will also be 1/2 and square root of 3 over 2. Keeping in mind that for the signs here, down in this quadrant, the y's are negative. So that's negative, and this is negative. And I know I'm writing that real small, you might not be able to see it, but okay, if I come straight over from here to this point, this is also going to be square root of 3 over 2 and 1/2. And this one, if I come straight over, and since I'm getting ready to draw my last one, let me show that. As close as I can draw to a straight line. Use your imagination. So come straight over to there. So again, this is going to be the same values. So this will be 1/2 and this will be square root of 3 over 2. This quadrant, everything's negative, so that's negative, 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 negative. And that's how you can build a unit circle. Okay, now I'm gonna start a new page here because we're going to use one that I already have loaded. We'll use this in the problems because I need the space on my tablet. Okay, let's take a look at this example here. We got negative 1/4 and negative square root of 15 over 4. The instructions say that our point is on a unit circle and it corresponds to real number t. Find the exact values of the 6 trig functions of t. Well, they're specifically telling us that it falls on the unit circle, which means we're going to use our formulas. Cosine is equal to x. Sine is equal to y. Tangent, let me get my, tangent is equal to y over x. Secant is equal to 1 over x. Cosecant is equal to 1 over y. And cotangent is equal to x over y. Well, for this one here, they give us a point, so this is our x and this is our y. So cosine is going to equal to your x, which is negative 1/4. And I'll go ahead and write secant down while I'm here. Secant is the reciprocal of this fraction flipped, so it'll be 4 over negative 1 or negative 4. Now sine is going to equal to our y, which is negative square root of 15 over 4. And cosecant is going to equal to the reciprocal of this, the fraction flipped. So this will be 4 over negative square root of 15. Can't have a square root of 15 down below, so I'm going to multiply top and bottom by the square root of 15. I'll put this negative up on top at the same time. So I'll multiply top part by square root of 15, and I'll multiply the bottom part by square root of 15. And that gives us negative 4 square root of 15 over 15. Tangent is equal to y over x, so I'm going to have negative square root of 15 over 4 all over negative 1/4. Now the 4's can cancel away. If you have a single fraction on top, single fraction on the bottom, they both have the same denominator. You can cross those out. Negative divided by negative is positive, and square root of 15 over 1 is going to give us a square root of 15. Now cotangent. Cotangent's the reciprocal of tangent, so I'm going to flip this fraction right here. So I'll have 1 over square root of 15. Can't have a square root down below, so multiply top and bottom by the square root of 15, and we get square root of 15 over 15. And those are our 6 trig functions. Okay. Now this one, I want you to go ahead and try, the students. And again, same instructions, and we got given a point. So at this point, pause the video and give the students time to work on the problem. And then once appropriate time has passed, then go ahead and unpause the video, and they'll see the solution for this. Okay, let's take a look at the solution of this problem. We got 1/5 and negative 2 square root of 6 over 5. Now this is our x and this is our y. Remember, cosine is equal to x, which is equal to 1/5. The reciprocal that goes with that is secant. Secant is equal to 1 over x, and basically we flip this fraction right here. Take a reciprocal of it. So that'll be 5 over 1 or 5. Now sine. Sine is equal to y, which is negative 2 square root of 6 over 5. And we'll go ahead and take a look at the reciprocal of that. Cosecant is 1 over y. So we're going to flip this fraction. Take reciprocal of it. So we got 5 over negative 2 square root of 6. Can't have a square root of 6 down there, so we'll multiply the top and bottom by the square root of 6. That's how you can always get rid of a square root in the denominator. So that gives us 5 square root of 6 over negative 2 times square root of 6 times square root of 6 is 6. I'll go ahead and put that negative up on top. So we got negative 5 square root of 6 over 12. Tangent. Tangent is equal to y over x. So we got negative 2 square root of 6 over 5 over 1/5. 5's would cancel, and we got negative 2 square root of 6. Let me put over 1. And that gives us negative 2 square root of 6. The reason why I put it over 1 is because it makes it a lot easier to flip this cotangent, the reciprocal of it. Okay, cotangent is equal to x over y, so we'll flip this fraction. So we'll have 1 over negative 2 square root of 6. Can't have a square root of 6 in the denominator, so we multiply top and bottom by it. We get square root of 6 over negative 2 times, and square root of 6 times square root of 6 is 6. So that gives us square root of 6 over negative 12, and I can put the negative up on top if I wanted, but those are our answers. And let me just double check myself there. Yeah, that looks right. I'm not doing this off a script, so if you find a mistake, that's very possible. Now I'm gonna undo this to clean off my tablet. If I start a new tablet too many times, it crashes, and it's much easier for me just to keep doing the undo. There we go. Okay. Let's take a look at our next problem. We want to find the exact value. Do not use a calculator. And that's true unless I say to use a calculator, round it, then throughout the entire test we want exact values. You'll miss a lot of points if you plug everything in the calculator, I guarantee you that. Now 14 pi over 3. We want to find the exact value. For 14 pi over 3, as I look around my unit circle, I don't have a 14 pi over 3 on my unit circle. But we can, remember, subtract 2 pi. And that puts us back to the same place on our unit circle. Well, I need to get a common denominator, which would be 3. So we got minus 6 pi over 3. Because 6 divided by 3 gives you 2. Now, if you saw that that wasn't quite enough, you could have actually done another 6 pi over 3, which would have gave us 12 pi over 3. So instead of subtracting 2 pi, you could have subtracted 4 pi, 6 pi, multiples of 2. But anyway, we got cosecant 14 minus 6 gives us 8 pi over 3. That isn't enough, so I'm going to subtract another 6 pi over 3. And 8 pi minus 6 pi gives us 2 pi over 3. And that gets us to where we want on the unit circle. So we got 2 pi over 3. Where's 2 pi over 3? Okay, right here. So we're working with this point. Now remember, cosecant is 1 over y. So we're going to 2 pi over 3. And here's our y part, square root of 3 over 2. So we got 1 over square root of 3 over 2. Never want a complex fraction inside of a fraction. So we're going to flip the bottom fraction, multiply times the top. So we got 1 times 2 over square root of 3, which is 2 over square root of 3. Never want a square root left down in the denominator, so multiply top and bottom by the square root of 3. So we got 2 square root of 3 over 3. And that's our answer. Okay. Now this is a second try it now problem. So same instructions, and we got secant 22 pi over 3. Go ahead and pause the video at this point and give the students some time to work this problem out. And then once they get done working it, go ahead and unpause the video, and they'll be able to see the solution. Okay, let's take a look at this problem. We got secant of 22 pi over 3. Well, as I look at my unit circle, 22 pi over 3, I don't have it anywhere on here. So we're going to subtract off 2 pi. Now, remember what 2 pi is in terms of this denominator. 2 pi is 6 pi over 3, because 6 divided by 3 is 2. Well, subtracting 6 pi isn't going to get there as fast as maybe what I want. Although, as I sitting here explaining it over and over, it probably would. But if I take a look, I could subtract 12 pi, 18 pi, or 24 pi. Well, if I subtract 24 pi, that's too much. So let's subtract 18 pi. So we're going to have 22 pi over 3 minus 18 pi over 3. Now 18... see, yeah, too early in the morning. Okay, yeah, 18 divided by 3 is 6. So 6 pi. So remember, we can add or subtract multiples of 2 pi. 2 pi, 4 pi, 6 pi, and so forth. Wake up here eventually. Okay, so 22 minus 18 gives us 4 pi over 3. And 4 pi over 3 is on our unit circle. As we scan around here, here's 4 pi over 3. So working with this point right here. Now remember, secant is 1 over x. So we're going to have 1 over, and we'll come down here, 4 pi over 3. The x is negative 1/2. So we'll put a negative 1/2 there. Now whenever you have a single fraction in your denominator, you can flip it and multiply it times your top part. So this becomes 2 over negative 1, which gives us negative 2. And that's our answer. Okay, actually I'm going to clear off that page. There we go. And next problem. Another one where we want to find the exact value. So we've got cotangent, 31 pi over 6. Well, as I look at my unit circle, 31 pi over 6 obviously isn't anywhere in our unit circle. Now, you can, instead of try to change them to fraction form, you can change this to a mixed number. Now, cotangent of 31 pi over 6 would be 5 and 1/6 pi. Now, 31 divided by 6 is 5 with a remainder of 1. That's why we get this. Now, that's beyond our unit circle, because our unit circle goes up to 2 pi. So I can subtract multiples of 2 pi. I can subtract 2 pi, 4 pi, so forth. Okay, so if we got 5 and 1/6 pi, and if I subtract off, looks like if I subtract 6 pi, that's too much. So I'll subtract off 4 pi. This is another way of doing that, like the example I just did, but work with mixed numbers. Well, 5 minus 4 is 1, so that gives us 1 and 1/6 pi. And if I put that back into improper fraction form, 1 times 6 is 6, plus 1 is 7, so we got 7 pi over 6. And here's 7 pi over 6, so we're going to be working with this point. Okay, now remember, cotangent is equal to x over y. So cotangent 7 pi over 6, this is x, this is y, so I'm going to have negative square root of 3 over 2, that's my x, over, and then negative 1/2. Now negative divided by negative is positive, the 2 is going to cancel, and square root of 3 over 1 gives us square root of 3. And that would be our answer. Okay. So on this this problem right here, same instructions. I want to find the exact value. Do not use calculator. We got tangent 17 pi over 6. At this point, go ahead and pause the video and give students time to work this problem. And then when it appears like they're done, then go ahead and unpause the video, and then they can see the solution and compare it against their work. Okay. Well, let's take a look at this problem now. You got tangent of 17 pi over 6. Now if I change this to a mixed number, let's see, that goes 2 and 5/6 pi. Let's see, 12, 17, yeah, 2 and 5/6. Now obviously that isn't on the unicircle because it's gone past 2 pi, so I need to subtract 2 pi. So I got tangent of 2 and 5/6 pi minus 2 pi, which ends up giving us tangent of 5 pi over 6. Which, if we look in our unicircle, 5 pi over 6, as we sit here and scan it, we have a 5 pi over 6, which is right here. So this is our point we're working with. Now remember, your tangent is equal to y over x. So at 5 pi over 6, this is x, this is y, so I'll have 1/2, that's our y, over, and then the x part, so over negative square root of 3 over 2. Well, we got 2's in both those denominators, so those cancel. So I got 1 over negative square root of 3. I'll put the negative up on top. We don't want the square root in denominator, so we multiply top and bottom by the square root of 3. So we're going to have negative square root of 3 over 3. And that's our answer. And let me clean off those pages. Okay. And let's take a look at number 4. It says find the exact value of each expression. Do not use a calculator. So we got 5 sine of 2 pi over 3, cotangent of 11 pi over 6, minus tangent of pi over 3. Well, first thing to notice, 2 pi over 3, 11 pi over 6, and pi over 3, none of those are greater than 2 pi. So if I go to my unicircle, I'll find all those on there. Now sine. Sine is equal to y. Cotangent is equal to x over y. And tangent is equal to y over x. So we're pretty much just going to look on our unicircle and see what all these values are. So 2 pi over 3, well, here's 2 pi over 3. Here we got x and y, and we said sine was a y. So we're going to have square root of 3 over 2. 11 pi over 6. Just scan through. Here's 11 pi over 6. Here's our point. And we said cotangent is x over y. Well, the x is square root of 3 over 2 over y, which is negative 1/2. Minus tangent of pi over 3. Well, here's pi over 3, and this is our point we're working with. Tangent is equal to y over x, so y over x, so we've got square root of 3 over 2 over 1/2. Okay. Well, let's do some simplifying now. So we got 5, and we got square root of 3 over 2. Now, whenever you have a single fraction down below, you can flip it, take a reciprocal of it, and multiply times your top part. So we got square root of 3 over 2 times 2 over negative 1, minus, same idea here, so we got square root of 3 over 2 times 2 over 1. So we got 5 square root of 3 over 2. Those 2's cancel, and we'll have negative square root of 3. minus, those 2's cancel, and we got the square root of 3. Well, we'll try it again. Put the negative out in front, so I don't have to worry about it. Square root of 3 times square root of 3 is 3. So that gives us 3 halves minus square root of 3. That gives us negative 15 over 2 minus, and I'm going to put that over 1 because we want to merge this into a single fraction. Common denominator would be 2. So we got negative 15 over 2 minus, multiply top and bottom by 2. So we got 2 square root of 3 over 2, which gives us negative 15 minus 2 square root of 3 over 2. It's assuming I made no basic math errors. I'm kind of questioning myself here, so let me go through and just double check. Should play some Jeopardy music while you're waiting. Okay, that looks right. If not, I won't be there for you to discover it's wrong. Okay, here's one for you to try now. Same instructions. Find the exact value. Do not use a calculator. And at this point, pause the video and give students time to work this problem. And then after they're done, as before, go ahead and unpause the video, and I'll show the solution for it. Okay, had to grab a drink. Let's take a look at this problem. We got negative 2 cosecant of 4 pi over 3 tangent of 5 pi over 6 minus sine of pi over 3. Notice that these are all on the unit circle, so that works out well. Now cosecant, and when I say on the unit circle, I'm talking between 0 and 2 pi. Cosecant is equal to 1 over y. Tangent is equal to y over x. And sine, remember, is equal to y. So, let's go look up this one. We got 4 pi over 3. So scan through my unit circle here. Here's 4 pi over 3. So this is the point we're working with. And we want y. So the y part is negative square root of 3 over 2. Now tangent. Tangent is equal to y over x, and we're looking at 5 pi over 6. Here's 5 pi over 6 on our unit circle, so here's our x and our y. We said we want y over x, so we're going to have 1 half over negative square root of 3 over 2. Minus sine of pi over 3. Well, here's pi over 3. Sine is our y, which is square root of 3 over 2. Okay, now let's do some simplifying. Now I'm going to flip this fraction, multiply it times your top part, and that gives us 2 over negative square root of 3. And on this one, do the same thing. So I got 1 half times 2 over negative square root of 3 minus square root of 3 over 2. Let's see, that gives us negative 2, and then 2 over negative square root of 3. 1 time, or these 2's cancel, I should say. 1 over negative square root of 3 minus square root of 3 over 2. Now I'm going to multiply the top parts together. Negative 2 times 2 is negative 4 times 1 is negative 4. And I'll multiply the bottom parts together. Negative times negative is positive. Square root of 3 times square root of 3 is 3. Minus square root of 3 over 2. Now we want to get a common denominator, which would be 6. So in our first fraction, we multiply the bottom part by 2, so we multiply the top part by 2. That's negative 8. In our second fraction, we multiply the bottom part by 3, so we multiply the top part by 3. So that gives us 3 square root of 3. So we end up with negative 8 minus 3 square root of 3 over 6. And that's our answer. Now, assuming no basic math error. Let me clear off the tablet. Even if there's a basic math error, you understand the general principle. Doesn't mean all accept basic math errors on the test, but all of you are younger than me. You have fresh minds. Okay, let's take a look at this one. We want to find the exact values of the 6 trig functions of the given angle. If any are not defined, say not defined. Do not use a calculator. So we got negative 7 pi over 3. Well, first thing I notice is that this is not on the unicircle. So I need to add 2 pi, or possibly even add more than that. Remember, 2 pi is equal to 6 pi over 3, because 6 divided by 3 gives you 2, to get the same denominator. Now, if I add 2 pi or 6 pi over 3, that's not enough. So what I want to do is I want to instead add 4 pi. So we're going to have negative 7 pi over 3 plus 12 pi over 3. Multiples of 6, 6, 12, 18, 24. And let's see, what's that give us? 5 pi over 3. Now after we get that, we want to find the exact values of the 6 trig functions. And so our cosine, remember, is equal to x. So I'm looking at 5 pi over 3. So I'm scanning around. Here's 5 pi over 3. The x is equal to 1/2. Now sine is our y. 5 pi over 3, sine our y is negative square root of 3 over 2. And tangent is equal to y over x. So we're going to have negative square root of 3 over 2 over 1/2, which gives us negative square root of 3 over 1. The 2's would cancel since they have the same denominators, and which gives us negative square root of 3. Secant is the reciprocal of cosine, so it'd be 2 over 1, or 2, or you could use the formulas if you wanted. Cosecant is the reciprocal of sine, so we're going to have 2 over negative square root of 3, and multiply top and bottom by the square root of 3, and I'll move the negative up on top. So we got negative 2 square root of 3 over 3. And cotangent is equal to the reciprocal of tangent, so I'll flip this fraction. So we'll have 1 over negative square root of 3. Multiply top and bottom by the square root of 3 and move the negative up on top. So we're going to have negative square root of 3 over square root of 3 times square root of 3 gives you 3. And those would be our 6 answers. Okay. Now this is our 5th try it now problem. So go ahead and same instructions. We got negative 13 pi over 3. Go ahead and pause the video. Give students time to work this problem. And after they've had some time, then as always, unpause the video. I'll quit saying that. Whenever you see the red, just pause the video and let them work it. And then when they're done working it, then play it and they'll see the solution. Okay, let's take a look at that problem. We've got negative 13 pi over 3. Well, as before, this isn't a unicircle, so we need to add 2 pi. 2 pi is same as 6 pi over 3. That's 2 pi. That isn't enough, though. So if I look at multiples of 6, next one is 12 pi over 3, which is the same as 4 pi. Well, that's bad. That's 2 pi. That's not enough. So my next one is 18 pi over 3, which is the same as 6 pi. So we're adding multiples of 2 pi. Okay, so we got negative 13 pi over 3 plus 18 pi over 3, which gives us, is that the same as the last one? 5 pi over 3. Well, same values then. I didn't realize that. I just made these up. So I won't sit there and go through it, but it's the same thought process as the one above. Then gives you the same answers. Let me clean that off. I even have worse luck in algebra because I sit there and make these problems up out of my head, and you think you're being random, but you're not actually being random. There's a pattern to what you do. Okay, this is a calculator-based one. We want to find cosecant of 22 degrees. Now, we're always going to round 4 decimal places. So keep that in mind. So we've got cosecant 22 degrees. We don't have cosecant on our calculator. But remember, cosecant is equal to 1 over sine. So we can rewrite this as 1 over sine of 22 degrees. Now notice the degree mark. That means we need to make sure our calculator's in degrees. Should have had my calculator up and running, but I guess I could play Jeopardy music while you're waiting. Okay, there we go. 1 divided by sine 22 degrees. Let's make sure we're in degrees. So I'm pressing my mode. And mine says degrees. If yours doesn't say degrees, down arrow to that line, right arrow, put your flashing cursor on degree and press enter 1 time. There's other ways you could do that, but I like to specifically choose which mode I'm going to be working with so I don't have to worry about putting the degree mark on there. So 1 divided by sine of 22, and then press enter. So I got 2.6695. It actually says 6694, but since this is 5 or greater, we round up. And that would be our answer. Okay. Go ahead and try this one. Same instructions. It's a calculator-based problem. It's got a little bit of a trick to it, though. I'll see if you can figure out what it is. So, again, pause the video. Okay, let's take a look at this one. We got cosecant of 56. This isn't a typo. Notice I did not put a degree mark on there, which tells us it's in radians. Now, we still don't have the cosecant on our calculator, so we'll have to use the fact that cosecant is equal to 1 over sine. But I want to make sure I'm in radians now. So I'm going to press my mode, and then I'm going to go down to the radian degree line, press enter on radians. Second mode, exit out, and then I'll do 1 divided by sine, no memory, 56, and then press enter. And we'll get negative 1.917. Then we got 3 with a 5 to the side, so it rounds up, so it'll be a 4. And that would be your answer. So be very careful anywhere on the test. Look to see if it's got the degree mark. If it doesn't have the degree mark, then it's automatically radians. Even if it looks like degrees, it doesn't matter. That's our whole basis on which one do we use. Okay, let's take a look at this problem. Let me clean up my tablet here. Now it says a point on the terminal side. A point on the terminal side of an angle theta in standard position is given. Find the exact value of each of the 6 trig functions of theta. So we got 2 and we got negative 10. This is no longer on the unit circle. So the formulas we're going to be using is we got cosine is equal to x over r. We got sine is equal to y over r. We got tangent, which is equal to y over x. We got secant, which is equal to r over x. We got cosecant, which is r over y. And then we got cotangent, which is x over y. And r is going to be derived by this formula. R squared is equal to x squared plus y squared. Or if I were to go ahead and drop the second power, we can put square root around this. And we got r is equal to square root of x squared plus y squared. Well, to use these formulas, you need 3 items. You need x and y. Well, that's easy. We're given x and y here. And you also need r. But we just looked at a formula to help us find r. So first off, let's find r. So r is again equal to the square root of x squared plus y squared. So x is 2, so we've got 2 squared plus negative 10 squared. 2 squared is 4, plus negative 10 squared is 100. So we got r is equal to square root of 104. And what is that? 2 times 52, 2 times 26, 2 times 13, 26, 52, 104. Okay. Remember, we're looking for a pair of somethings for our square root, so bring a pair of 2's out in front. So we've got r is equal to 2 square root of 26. Now we're ready to plug them into our formulas. So cosine is x over r. X was 2 over r, which was 2 square root of 26. 2's would cancel, so we got 1 over square root of 26. Multiply top and bottom by square root of 26, and we got square root of 26 over 26. Sine is equal to y over r. So that's going to be negative 10 over 2 square root of 26. 10 and 2 both divisible by 2, so that gives us negative 5 over square root of 26. Multiply top and bottom by square root of 26, and we got negative 5 square root of 26 over 26. Tangent is equal to y over x, so we're going to have negative 10 over 2, which is negative 5 over 1, or negative 5. Sometimes I do that fraction just so that it's easier to see for reciprocals. Secant is going to be cosine flipped. So I'll flip this fraction right here, 1 over square root of 26. So that's square root of 26 over 1, or simply square root of 26. Cosecant is going to be sine flipped. And I'll flip this fraction right here. So we'll have square root of 26 over negative 5. And that's our answer. And cotangent, I don't care where you put the negative at, top, bottom, out in front. Cotangent will be tangent flipped, the reciprocal. So negative 5 over 1 becomes 1 over negative 5. And those are our six answers. Okay. Go ahead and try this one now. Same instructions, and we got negative 4, negative 1. So we'll go ahead and pause the video and give them a chance to work. Okay, let's take a look at this problem. We got negative 4 and negative 1. Same instructions. So this is x and this is y, and same formulas. So we need to find r. R is going to equal the square root of x squared plus y squared. So we're going to have negative 4 squared plus negative 1 squared, which negative 4 squared is 16, negative 1 squared is 1, so we get r is equal to square root of 17. Looks like this one might be a little bit easier than the last one. Okay, remember cosine is equal to x over r, so we're going to have negative 4 over square root of 17. Can't have the square root in the denominator, so I'll multiply top and bottom by the square root of 17. So I got negative 4 square root of 17 over 17. Sine is going to be y over r. So that'll be negative 1 over square root of 17. And multiply top and bottom by the square root of 17. So that gives us negative square root of 17 over 17. Tangent is y over x, which would be negative 1 over negative 4, or simply 1/4. Secant is going to be r over x, which is the cosine flipped. So we'll have square root of 17 over negative 4. Cosecant is r over y, which is sine flipped, the reciprocal of it. So that'll be square root of 17 over negative 1, or negative square root of 17. And cotangent is going to be x over y, and it'd be a tangent flipped, the reciprocal of it. Well, 1 over 4 becomes 4 over 1, or simply 4. And those would be our answers. Let me clean off this page. Grab a drink while it's clearing it off. Try it again. There we go. Okay, number 9. Use the fact that trig functions are periodic to find the exact values of each expression. Do not use a calculator. Okay, so we got cotangent of 20 pi over 3. Well, periodic means you can add or subtract 2 pi over and over. And this isn't in the unicircle, so I want to subtract 2 pi. Now, even more than that, if I get a common denominator, this is a 3, so my common denominator would be 3. This is the same as 6 pi over 3. That isn't enough. So if I go to 4 pi, that would be 12 pi over 3, which is not enough. And if I go to 6 pi, that's going to be 18 pi over 3. Notice what I'm doing. I'm adding 6's over and over. And it looks like the right amount. So we'll have cotangent of 20 pi over 3 minus 18 pi over 3. And that's going to give us cotangent of 2 pi over 3. Now remember, cotangent is x over y. So let's go look up 2 pi over 3 on our unicircle. So we're scanning through here. Here's 2 pi over 3 to work with this point right here. Cotangent is x over y. So x over y. So we're going to have negative 1/2 over the y, which is square root of 3 over 2. Now those 2's are going to cancel, and we got negative 1 over square root of 3. Multiply top and bottom by the square root of 3. And we got a negative square root of 3 over 3. And that's our answer. Okay. Go ahead and same instructions here. We want to find cotangent of 31 pi over 3. So go ahead and pause this and let the students work the problem. Okay, now let's take a look at this one. Okay, cotangent of 31 pi over 3. Well, that's obviously not on unicircle. I could subtract 2 pi, which is 6 pi over 3, but that's not enough. 4 is not enough. If I went to even 6, it wouldn't be. If I keep adding this, I got 12 pi over 3, 18 pi over 3, 24 pi over 3, 30 pi over 3. Next one would be 36 pi over 3. Well, that's too much. So I can subtract 30 pi. So I got cotangent of 31 pi over 3 minus 30 pi over 3 gives me cotangent 31 minus 30 is 1, so 1 pi or simply pi over 3. Just like before, remember cotangent is x over y. So I'm going to pi over 3, which is right here, x over y. So we're going to have 1/2 over square root of 3 over 2. Well, the 2's would cancel, and we'd have 1 over square root of 3, multiply top and bottom by the square root of 3, and we got square root of 3 over 3. And that's our answer. Now let me clean that page off. And let's take a look at this problem. We got cotangent of theta is equal to negative 2/5, and secant is greater than 0. And I want to find the exact value of each of the remaining trig functions. Well, remember, we have cosine is equal to x over r, sine is equal to y over r, tangent is equal to y over x, secant is equal to r over x, cosecant is equal to r over y, and cotangent is equal to x over y. Now let's talk quadrants. Secant, which is r over x, and r doesn't matter because it's always positive, but this is saying x is greater than 0. Well, x is greater than 0 or x is positive in these two quadrants. Now this is saying cotangent is negative. Now cotangent is equal to x over y, and the only time it would be negative is when the signs are different, when one's positive and one's negative. Well, the quadrants I'm looking at is this quadrant here because the x is negative and y is positive. And I'm looking down here because the x is positive and the y is negative. So where they're both true is quadrant 4. So that's where we're going to be working. In quadrant 4, now cotangent is equal to x over y. So I'm going to rewrite this as cotangent is equal to 2 over negative 5. Reason why I do that is cotangent is x over y, and in quadrant 4, x has to be positive. Okay, so this is going to be x, and this will be y. For our formulas, we need 3 items. We need x, y, and r. Well, r is going to equal the square root of x squared plus y squared. Well, x is 2, so we got 2 squared plus y, which is negative 5. So that gives us 4 plus 25, or 29. So r is equal to square root of 29. Now cosine. Cosine is equal to x over r. So we're going to have 2 over square root of 29. Multiply top and bottom by the square root of 29. And we got 2 square root of 29 over 29. Now sine is equal to y over r. So that would be negative 5 over square root of 29. Multiply top and bottom by the square root of 29. And we got negative 5 square root of 29 over 29. Tangent is y over x. So we'll have negative 5 over 2. Secant is cosine flipped. And I'll flip this fraction. So that'll be square root of 29 over 2. Cosecant is sine flipped. So that'll be square root of 29 over negative 5. And cotangent is tangent flipped. So that'll be 2 over negative 5. And those would be my 6 answers. So go ahead and try this one. And pause the video. Then after they get done working a little bit, then go ahead and unpause it and take a look at it. Okay, let's take a look at this problem. We got cosecant is equal to negative 4. And I want to put that over 1 because we know it needs to be in fraction form. And tangent is greater than 0. Let's talk about quadrants first. Tangent is greater than 0. Well, tangent is greater than 0 when the signs are the same. When the x and the y are both positive or both negative. Well, they're both positive here and they're both negative here. Now cosecant is equal to r over y. And r is always positive, so we're basically saying y is negative. Y is negative here and here. So where they're both true is quadrant 3. So that's where I'm going to be working. Now cosecant, remember, is r over y. So I'm going to rewrite that. Cosecant is equal to 4 over negative 1. Reason why is because r is on top and it has to be positive. And y is negative and it's on the bottom, so again it has to be negative there. Okay, so this will be r and this will be y. We need 3 things for our formulas. We need x, we need y, and we need r. R is 4, y is negative 1. We got our formula, x squared plus y squared is equal to r squared. Y we just said was negative 1, so that's negative 1 squared is equal to r squared, so 4 squared. So we got r squared plus 1 is equal to 16. Take the 1 over, and we'll get x squared is equal to 15. Drop the squared, put a plus or minus square root around the other side. But in quadrant, that's what we're working with, 3, x is negative, so we're going to keep the negative. So x is going to equal negative square root of 15. Let me come up here and do it. Cosine is x over r. X is negative square root of 15 over r, which is 4. That worked out nice. Sine is y over r, which would be negative 1/4. Tangent is y over x, which would be negative 1 over negative square root of 15. Negatives cancel and multiply top and bottom by the square root of 15, and we got square root of 15 over 15. Secant is cosine flipped, which would be 4 over negative square root of 15. Move the negative up on top and multiply top and bottom by the square root of 15. So we got negative 4 square root of 15 over 15. Cosecant's given. It's negative 4. Cotangent is tangent flipped. And I'll flip this fraction. Negatives cancel. And I'd have square root of 15 over 1, or just simply square root of 15. And those would be your answers. Assuming no basic math error. Or assuming no error, period. Definitely I'm not perfect when I'm creating these. Okay, now our next one. It says use the even and odd properties to find the exact value of each expression. We've got cosecant of negative 60 degrees. Well, cosecant's odd, so from our odd identities, you can take negative and put it out in front. Now remember, cosecant is equal to 1 over y. So let's go look up 60 degrees in our unit circle and see what it's equal to. So here's 60 degrees, here's x, and here's y, so our y is square root of 3 over 2. 1 over y. Well, we'll flip that fraction, multiply times the top parts. We got negative 2 square root of 3. Multiply top and bottom by the square root of 3, and we got negative 2 square root of 3 over 3. And that's our answer. Okay, go ahead and pause the video and let them try this one, tangent of negative 30 degrees. Okay, let's take a look at this one. Tangent is also odd, so I'll take negative, put it out in front. And remember, tangent is equal to y over x. So let's go look up 30 degrees on a unit circle. Here's 30 degrees. And this is our point, y over x. So I'm going to have 1/2 over square root of 3 over 2. Now 2 is going to cancel, so we got negative 1 over square root of 3. Multiply top and bottom by the square root of 3. And that would be our answer. Now the last thing in the review is to talk about the identities. Okay. Cosine, remember, is 1 over secant. And secant is equal to 1 over cosine. Sine is equal to 1 over cosecant. And cosecant is equal to 1 over sine. Tangent is equal to 1 over cotangent. And cotangent is equal to 1 over tangent. Those are our reciprocal identities. Now we also have that tangent is equal to sine over cosine, and I'm not putting the degrees on or the theta on here, but it's implied. And cotangent is equal to cosine over sine. Now we've already given our other the x over r and so forth, but those really aren't our identities we're going to use in one of the problems on the test. We got these. We also have sine squared plus cosine squared is equal to 1. And to derive the other ones, I could go through and divide everything by sine squared. If I divide everything by sine squared divided by sine squared is 1. Cosine squared divided by sine squared, well, cosine over sine is cotangent, so that would be cotangent squared. And 1 divided by sine squared is cosecant squared. So 1 plus cotangent squared is equal to cosecant squared. Now if I go through and divide everything by cosine squared, sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is secant squared. So tangent squared plus 1 is equal to secant squared. There'll be a problem involving the identities, and you have to remember those. Remember the sine, cosine, well, all the trig functions you can add or subtract 2 pi or 360 degrees, but even more than that, For tangent and cotangent, you can add pi or subtract pi, or you can add 180 degrees or subtract 180 degrees. Well, good luck on the test, and I'll see you once I get back.